Okay, it is growth because we see that this number right here is greater than 1. Okay, so how do I find out how much greater than 1 it is? You just subtract 1 from it. Okay, that's the long way. If it's growth, a lot of times it's easy. You can just look at those last two numbers as long as it's not more than 100%. Okay, so that's going to give you a 0.35, which how do we write that as a percent? 35%. Move it 2 places to the right. Okay, and that is 35%. We said growth. Okay. All right, growth or decay. This one is decay, we can tell because this number is less than 1. So your process is the same. You're still going to take the number and subtract 1. And when you do that, what's it going to give you? All right, and if I do it this way, it gives me a negative 0.56. The negative just means decay, so it is going to be 56% decay. Y'all can abbreviate with D and G for growth and decay. You don't have to worry about it. Okay? Alright, so next one, growth or decay? Growth in how much? Oh, then, like I said, if that's a 1, then it's just the numbers after, so it's going to be 14% growth. Okay? And the next one. Growth or decay? That is decay, so we're going to say 0.68 minus 1, so it is in fact 32% decay. All right, do that last one of those real quick, and then we get into a new one. Knock that one out real quick for me. So we'll get into a new type. Okay, what you got here? What you got here? All right, so the negative 0.11 means it is 11% decay, right? Okay. All right, now we get a little trickier, okay? Because what people want to say here is that the answer is growth or decay. Decay by how much?
Those are the ones.
Okay. The problem with that is in all the ones that we have just done, what is my exponent? X. What is my exponent here? Okay. So what I need you to do is I need you to do what's up?
Okay. Can I get it?
You can try. What you got?
Okay. Would it be 20% growth?
No.
Okay.
I mean, here's what I'm going to say. I'm going to say no. I don't know what it is that I calculate. Okay, I'll tell you why in a second. Okay, so it might be, but it's not just 4 times 4 times. Okay, so here's the difference. All right, I need you to go back to something that you know, with something we've covered, which is our exponent rules. Okay, remember this right here. If we had x to the 5th to the 3rd, what do we do with the 5 and the 3? Power to the power you multiply, right? So that will be this. Okay, basically what we're going to do is we're going to undo this. Okay, so we're going to write this as 0.5 to the 1/4 to the x, because if I put that that together and I simplify using my exponent rules, then that's the same thing as x over 4, correct? Okay? But now what I need you to do in your calculators, I need you to do what is 0.5 raised to the 1/4 power. All right, you give me 2 decimal places, around 2 decimal places. 0.84 to the x, right? So what I'm saying is that right there is the same thing. Is everybody with me? I moved the 1/4 in with the 0.5 and left the x outside. Okay? So now what is my rate? Is it growth or decay? It's still decay. Okay, that wasn't going to change. How much is it decay? 16%. Because 0.84 minus 1 gives you negative 0.16. Is everybody with me? Okay, so that's what you're going to be doing on the next few of these. Okay, so this time, what are we bringing inside with the 1.05? 2/3. So you'll actually type in your calculator 1.05. Okay, to the 2/3 to the x. Okay. And that gave you 1.03. Okay, so what is our rate of growth or decay? 3% growth. Okay? Yeah, because you move 2 places over.
How much do you pay?
$200. Alright, so 3% growth here. Alright, let's see what the next one is. My brother isn't smart, he doesn't do like that. Because he's not a cat. It's a whole different model. Alright, so what we got? What are we doing here? How do we raise here? 0.4 to the 3/4. What's that going to give me? 50? So that growth or decay? Decay by how much? 50% decay. Alright, so what you got? 3 more of those? Okay, knock those out real quick for me. Shouldn't take you long. 1.25 to the 2/5, what did that give you? 1.09? So that gave us what? 9% growth, okay? Alright, what about this one? It would have been 1/2 to the 1/4. What did that give us? 0.84? So that would be what? 16% decay. Okay, and then one more. Okay, so it'll be 1/5 to the 3/4, which gave us
0.299.
so we'll say 0.30. So that is what? 70% decay. Okay? So if there's nothing out there with the x, you're fine. You just do subtract 1 and we're good to go. If there's something out there with the x, you've got to put that inside first and then go on from there. All right. Is everybody good on rate of exponentials? Okay. So now we're going to jump into just some greatest common factor stuff. Okay. Y'all have done greatest common factor in years past. Okay. The majority of the time when you did greatest common factor, it was most likely with just numbers. Like, what's the greatest common factor between 4 and 12? 4, right? It's the biggest number that was divided by the number. Okay? It's the least common multiple. Okay? So, alright, so basically, what we're doing here is not greatest common factor. What would I do on this first problem? I would distribute, and when I do that, what's it going to give me? 3x minus 6. Okay, that's as simplified as it gets, and we're done. Okay, same thing down here on the bottom. What could I do first? A couple of ways you can do this. If you want to distribute first, that's perfectly fine. That would give you what? 4x to the second power plus 12x to the second power minus 5, right? Am I done yet? What can I do?
Wouldn't it be 20?
No, it's
You have to have it. It's a
I don't talk about it.
Oh, you're right, yes, no, you're right, that would be 20x, my bad. I was stuck on my squares, my bad, you got it. Okay, minus 20x, right? Okay, the other thing though that you could have done, and I don't care which way you do this, you could have combined these to begin with, and that would have made it 4x minus 5, which is still going to give you 16x squared minus 20x. Does everybody see that? So it doesn't matter whether you combine to begin with, if you combine on the right side, okay, you're still going to get to the same place. Okay, so this is what we have done. All right, we've done that kind of stuff. So today what we're going to be doing is I'm going to give you this, the 16x squared minus 28, and you're working backwards to give me the 4x times 4x minus 5. Okay, the only difference in today. All right, so, no, right here. All right. Okay, actually, don't write this. I'm going to go through this, but I'm not going to write it. I just want you to pay attention, okay? Because y'all don't have this. There's no need to flip your paper over and draw it. Just follow along, okay?
Yes, ma'am.
All right, 7x. That's basically the multiplication of what two terms? 7 times x, right? 7 times x gives me 7x. Okay, how about 21? 7 times 3, right? What do they have in common? 7. So 7 is their GCF. Okay, that's what I'm getting at. It's got to be something in common with both of them. So if I take the 7 out of both of them, what am I left with? X plus 3. Okay? That's what we're doing. Now, I'll be honest with you. You're going to be here a while for bigger numbers if you don't just learn your multiplication back. Okay? All right? So, in other words, that's what I'm going to do right here. I'm going to do the long way. I would not expect this from you. Okay, 40. That's technically what that is.
Okay.
40 is, that's prime factorization. Okay, I broke 40 down until none of these numbers can be broken down any further. Okay, 2 times 2 times 2 is 8, 8 times 5 is 40, right? And W to the 5th means I have 5 W's, right? All right, and then 50, 2 times 5 times 5, and then W to the 3rd means 3 W's, okay? So what do they have in common? They have a pair of 2's, a pair of 5's, and 1, 2, 3 W's, right? Okay, so on the outside I can put, what's 2 times 5?
10.
I can put 10, W to the 3rd, okay? And what am I left with? What's 2 times 2?
8. I'm at 4.
4. How many W's?
I'm thinking 10.
2, right? So W squared. Okay, what am I left with over here? Minus 5. Now, majority of you would have looked at 40 and 50 and told me that the greatest common factor between 40 and 50 is 10. You wouldn't have had to do the prime factorization. But my point is this. If you don't know your prime factorization, or if you don't know the largest one, don't just give up, okay? Start with something you do know. So, for instance, if we had 24 and 36, and somebody's like, oh, I can't think of what it is. I think it's 6. I think it's 6, right? If I divide by 6, that gives me what? 4 and 6. Can something go into 4 and 6? Yes, what? 2. And that gives me 2 and 3. Can anything go into 2 and 3? So instead of 6, it should have been 6 times 2, which is 12. So just because you might not can think of the greatest one off the top of your head, and you will be able to for most of these numbers, y'all. But there are some bigger numbers that you want. Doesn't mean you just don't do the problem. Okay? Start with what you do know and work from there. All right, so now let's get to what you've got. Real quick, on that third one, second one. Where do you think I could have gotten the W3 from? Like, what are my two exponents on my W's? In the problem. 5 and 3. Y'all, if it's in common, it can't be any larger than the smallest one of that. Okay? If we're talking about apples and oranges, okay? Somebody's got 5 apples and, well, let's just talk about money in general, okay? If you've got one of you has $25, one of you has $10 in 5, right? A 20 and a 5 and a 10 and and 2 5s. They only both have how many 5s? 1, right? That's only 5 they have in common. Then it's what's left. Okay? So there can't be more than 3 because after 3, this person runs out. They don't have any more. Okay, so it's always, you always choose your smallest exponent. That's kind of our rule of thumb. Okay, so we're going to start with our numbers first. What is our GCF between 18 and 45? Hang on, hold on. 18 and 45. You're thinking of what's the biggest number that will divide into both 18 and 45. Okay, you think it's 9. I'm going to double check it over here before I write it on that board. Okay, that's going to give me 2 and 5, right? Can anything go into 2 and 5? No, so we are correct. It is 9. What is our lowest number of x's? 1. So that's our GCF. So I'm going to put 9x out front, and then I'm going to divide, and what is left is my answer. So what is 18 divided by 9? 2. What about x squared and x? That would be with 1x, right? Because we subtract our exponents when we divide. All right, and what's 45 divided by 9? What happens to our x's? Here is your answer. Not super hard. I won't say it's easy. Not super hard. But you got to know your multiplication facts. Okay? GCF between 2 and 6. 2. Y'all, it can't be any bigger than the smallest number. All right, and what's our lowest number of exponents? X squared. Right? 2 is smaller than 3. Okay, so that's our GCF. So what am I left with when I divide 2x cubed by 2x squared? Just x. You can write 1x if you want to. 2 divided by 2 is 1. Well, I'm just going to put x. And then what am I left with on the second half of that? Minus 3 and my x squared cancel out. All right, see if you can do number 3 and attempt number 4. Okay. Hey, focus. All right, GCF between 12 and 15, what was it? 3x squared, right? Okay, so that gave me 3x squared outside and left me with 4 minus 5x to the third, okay? GCF between 6, 45, and 9. 3x to the third. I'm taking your word for it. I'll figure out if you're wrong here in a minute. Okay, so that goes outside, and I'm left with 2x squared minus 15, no x, plus 3x to the third. Okay, real quick eyeball check you can do to kind of make sure you're right. Make sure that inside of here, everything should have an x left, 15 doesn't, and nothing can go into 2, 15, and 3. Something can go into 15 and 3, but it does not go into 2, so that's how you know you're right. Are we good?
Yes.
Everybody good on GCF? Yeah. All right, let's do these last 2 right here, and then we'll move to the other set of notes for today. All right, not these last 2 right here out. 4? Okay, so you think it's 4d to the 4th, right? Which left you with what? 7 minus 8d. All right, GCF between 15 and 35? 5a7, which left you with 3a8 plus 7. Okay? All right, so we're going to stop there on GCF, and we're going to go to the second set of notes that we have for today. And we're just going to start initially the top line. Just so you know, none of the problems that you see on the ERC will look like this. Okay, this is just getting us to where we need to be. All right, what I want you to do on the top line only, okay, so the first 4 x's is we're going to multiply to get the top number, we're going to add to get the bottom number. So what is negative 8 times 5? Negative 40. And what is negative 8 plus 5? Okay, that's all you're doing. All the way across the first row. Multiply to get the top and add to get the bottom. Okay, fill those last 3 in real quick. Shouldn't take too long. Multiply to get the top, add to get the bottom.
I took this thing.
Okay? All right, what you got? What's the first one? 6 and negative 5, negative 40 and negative 6 and negative 24 and positive 5. Okay? Now, that's just so you understand the way the X works. But here's what's going to happen. Whenever we go into factoring, it's going to be the opposite. Okay? So you've got the top number. You've got what they multiply and add to get. Now you've got to tell me what two numbers multiply to give me 9 and add to give me 10. Okay? So, some of them will be simple. For instance, this one. What multiplies to give me 9 and adds to give me 10? 9 and 1. Pretty easy. Okay? Some of them will not be that simple. Okay? Negative 5 and 4. Okay, well, first of all, if your top number is negative, you know that one of your numbers has to be negative. No way you can get a negative, y'all. Okay? So, negative 5 and positive 4. Got to multiply to give me negative 5 and add to give me positive 4. What's the only thing that multiplies to give me 5? 5 and 1, right? So which one should be negative for me to have a positive 4? 1. 5 minus 1 is positive 4. If I put the negative on the 5, that gives me a negative 4. So there's only one right answer for every one of these problems. Okay? All right, negative 12 and 4, what you think?
2 and negative 6.
Okay, now, I heard somebody say negative 6, and then you stop. Does it matter whether I go 2 and negative 6 or negative 6 and 2? No. Addition and multiplication of the operations, that does not matter at all. All right, what about 8 and 6? Multiply to give me 8, add to give me 6, 2 and 4. Now, do you understand our process here? Multiply to get the top, add to get the bottom. Let's see how good you are. Let's see if you got them all right. What you got? Negative 7, negative 5. 3 and negative 7. Negative, okay, let me talk about this one for a minute. Most people miss that one based on the fact that you probably started with 10 and 3. Okay, because most people think 10 and 3 does give me 30, 10 and 3 does give me 13. But in order to get a negative 30, okay, then one of these has to be negative, right? If you do a negative 10, that gives you a negative 7. If you do a negative 3, that gives you a positive 7. There's no way to get the negative 13. There's only one right answer. Okay, what about this one? 3 and negative 1, and down here, 8 and negative 4, negative 9 and positive 5, negative 8 and positive 2, and negative 2 and positive 1. Okay, so y'all understand the point of the X. Okay, now, trig X's aren't going to be on the EOC. Okay, but we're going to use them for something. All right, so that takes us to here. Okay, this is what the actual problem will look like. Now, they won't have the X drawn for you. But when we start to see these are trinomials, okay? Quadratic trinomials. And when we start to see these, we're going to start filling in the X ourselves, okay? So you already have X's drawn on your paper, correct? Okay, so what we're going to do is we're going to take the first number, which is 1. And we're going to multiply it times the last number. What's that give me? That's going to be my top number. Okay, the middle number is my bottom number. And now we do what we were just doing. Give me two numbers that multiply to give me negative 24 and add to give me negative 10. Okay, 6 and 4 is everybody's first thought, but think about that.
-12.
-12 and +2. Okay, now, here's the only extra step I'm going to add. Okay, your answer's not going to look like this. It's not going to look like an X with a -24, a -10, a -12, and a 2. They're going to do this.
No.
That's all. That's it. They take the numbers, -12 and 2, they put them in a parenthesis with an X. Y'all, what would you do if you solved this problem? You would distribute, right? You know what you're going to get? A squared minus 10x minus 24. We've done this, right? I'm giving you these and we've worked it here. What was the backwards step? Now I'm giving you this and I need you to work it here. Okay? It's the only thing we're doing that's different. Alright, so on the next one, what's going to go on the top of my X? 1 times 27 is? Bottom? -12.
Yeah, I'm not.
Okay, what's next?
Oh,
Alright, well, hey, if you don't know, let's do this. Don't yell it out. Don't yell it out. For 27, we've got 1 and 27, and we've got 3 and 9. That's the only 2 things, right?
Yeah.
So which one will give me a 12? 3 and 9. In order to be a positive, they both have to be -3, -9. Okay, so how are we going to write our answer? There you go. You want me to? Okay?
Are you ever going to see a number that isn't 1?
You are tomorrow. That's what will be on the video that I teach you tomorrow when I'm not here.
Wait.
Your video?
Hurry up. You know what I'm working.
Okay, I'm with my hair.
Okay. All right. What goes in the top here? -40 and the bottom is. Now, the reason, I'll be honest, for today, because Tom brings up a good point. For today, it's just the last number in the middle of it. Because the number in front of our square term is 1 all day today. Okay, tomorrow it won't be the case. Okay, so that's why I wanted to get you in the habit of multiplying the first time to last, because that's what you have to do. It just doesn't do anything if it's 1. Yes, sir.
That middle number was the same, right?
Yes, even tomorrow. It'll say that. Okay. All right, so -40 and -18, give me 2 numbers.
9 and -9. There has to be a 9.
Why?
Because 18 and 40 is different than 9.
You think so?
I'm guessing.
Oh my god, okay, I'm guessing numbers.
I agree. I mean, I like your thought process because I can get it. Can 9 go into 40 though?
Oh, shoot.
So listen, that's where you want to start. You want to ignore the adding because listen, anything in this world can add to give you 18.
-22.
Right? Hold on, everybody understand that. If I'm just looking for something to add to give me a number, it could be -4,870,000 and something else to give me a -18, right? So we want to look first at our multiplication.
So 4, 10, 85.
Right, so we got 4 and 10, we've got 8 and 5, we've got 2 and 20, and we've got 1 and 40, right?
Yeah.
So how can I get an 18? 2 and 20, and for it to be a -18, it needs to be a -20. This is what I expect you to do if you run into a roadblock. Okay, you've got calculators, start figuring it out. So our answer here should be F plus 2 and F minus 20. Also, just realistically, y'all, if you use X instead of F, it's okay. I don't care. Okay? See if you can try number 4. What you got? 36 and -13 is -9 and -4. So that's M minus 9 and M minus 4. Okay? All right, so let's, give me 1 second. I'm going to jump. These are the same way, okay? Y'all, the X just isn't there. So the first thing you do is draw the X. You fill it in the same way. Find your 2 sides, okay? Just want to jump real quick and make sure I get to Maybe not. Not so good. I mean, if not, we go to a blank page at least. You know, somewhere. Oh, whoa, whoa, whoa. Okay, let's jump right here for me, okay? So right here, everybody with me? Somewhere down there at the bottom? Okay, so right here is when we won't get through all of these notes today. On Friday when I come back, we'll try to finish the rest. You'll still do tomorrow's, and you'll do the worksheet that's based on these notes and tomorrow's notes, both tomorrow. Okay, we're going to put them together. So the first thing you're always going to look for is a GCF. Do I have a GCF between 3, 15, and 18? What is it? So that's the first thing I need to do. I need to factor out that 3. And when I do, what am I left with?
Negative 5 right now.
All right, hold on.
I'm doing it wrong.
Right, I'm factoring out a 3. So I'm left with x squared minus 5x minus 6, right? Okay, now you move to what we were doing. So just look right here. Can we Xbox that? What would go on the top? Negative 6. What would go on the bottom? Negative 5. Okay, so now let's try to find two sides that multiply to give me negative 6 and add to give me negative 5. Anybody? Negative 6 and 1. Okay, so you still write that, x minus 6 and x plus 1, but if this is my answer, will that get me back to the beginning? No, what am I missing? Because x times x gives me x squared, but what's my x squared supposed to have in front of it? I'm missing my 3. Okay? So that's the only difference, is now the GCF has to be in front, but then you still do exactly what we were doing after that. Okay, let's do one more of these, and then we'll call it a day. GCF between 4x squared, negative 32x, and negative 36. We'll go with 4. Okay, so now we're going to Xbox that. Gives me a negative 9 and a negative 8, right? Two sides. Negative 9 and 1. So I've got x minus 9 and x plus 1, and then we're going to put a 4 in front. We good? Is everybody with me? So GCF we're fine on. Factor with A is 1 we're fine on unless it requires the GCF.